bunch of, like I said, vocabulary. So the first thing that we talk about are parallel lines. Any idea what parallel lines mean?
They will never cross, or never cross.
Okay. Two or more lines that never intersect. See, we're older now, so we say intersect instead of cross. See how smart we're getting?
We went over this lesson.
Great. So, here's the question. Don't say anything out loud. Let everybody think for a second. Why? Why does that happen? Everybody think they got an answer?
Yes.
What? Why are parallel lines parallel? Why don't they ever cross? Why don't they ever intersect? Everybody think they got an answer?
Yeah. They don't go the same way. Like they both go the same way, but they never.
They could both go down and still cross.
Huh? I know. That's no. That's
Out.
Oh, like, they're not in the same line, but they're two different equations that continue in the same direction.
Because they're the same degree.
Oh, you're.
because of a square.
Mine's dumb, I'm not gonna say.
Same slope.
Boom!
Oh.
That was really bad.
Parallel lines are parallel because they have the same slope.
Then we already went that.
I would think we probably said that sometime. So, draw two lines. How do I know that's a line?
Because it doesn't end.
Arrows.
My arrows, right? So, are those two lines parallel?
Yes. No, well, not really.
Yes, they are.
Not really.
Yes.
They're both like slanted in different angles.
No, they're not. It's not gonna be a perfect line.
So, in a sense, he's right. Remember when we talked about a right angle? What made a right angle definitely a right angle?
Box.
The box did, right? So how do we know exactly that these are parallel lines? This is huge now. They put little, like, arrows on there. So now you can't argue that those are parallel. Okay? Sometimes they color them in like this, and a lot of times in your book or in math books, they're red. I don't know why. So sometimes they, some of the geometry kids come up and say that this looks like a play button, right? On your phone, if you hit the play button. And if there's multiple sets of parallel lines, then you'd have like two arrows on your other set of parallel lines. And so then it looks like a fast forward button. You know what I'm saying?
Yeah.
So just kind of a way to think about it. And then, so basically, I would call this line M and line N. Okay, and when you call a line by one letter, these are called script letters, right? Script letters are just basically italicized letters or in cursive, right? So, what's the symbol for parallel? How do I show or write down that line M is parallel to line N?
That would be equal as.
Two lines.
Just two lines. So I'm going to write M, cursive, is parallel to N. But this symbol right here is my symbol for parallel.
Do they have to be cursive?
They have to be cursive, yes.
Oh, you
Are you
did.
doing
Yeah.
oh.
You did it wrong because the N has two loops.
So, from there then we introduce another. So now I'm going to put a line across those two parallel lines. And this line that I just made right here is called a transversal. And this transversal is just a line that intersects two or more parallel lines. And we'd call this something else, I don't know. I don't even know what that letter is. R, okay. We'll call it R. So we can draw a transversal whenever we want, and it just has to go through it and it has to cross our other lines. From here then, would you see that when I drew my transversal across my two parallel lines that there's a bunch of angles that were formed? Can you see those angles? Okay. So if I started right up here and I named this angle 1, 2, 3, 4, and then 5, 6, 7, and 8. Everybody okay with all that?
Yeah.
Okay. So every time that I draw a transversal across parallel lines, I'm going to realistically form those 8 angles every single time. And I don't have to necessarily write them in that order. I can write them in any order that I want. But do you see that these 4 are basically in a group and then these 4 are basically in a group?
Yeah.
Okay?
Are the ones on the right always going to be a cube?
No. Not if I draw it this way.
The ones on the top right.
Not if I draw it this way. If I draw my line this way, then the top right ones are
Oh,
obtuse.
go in that direction.
What do you mean?
Like the same direction. Well, top right one's always be a cube.
Good thinking about. Good thought, I mean. We're getting there.
Oh, would they always be the same angles? Would they always be the same degree on the top one and the bottom one?
Good thinking. We're getting there. It's a great thought.
If that one's obtuse, will that one always be obtuse?
Good thinking. We're getting there. You guys are on fire. Okay?
Is that good?
Everybody good with this?
Yeah.
Okay? From there, then we introduce words like interior angles. What's the word interior mean?
Inside.
Inside. So these are angles in between the parallel lines. So don't say it out loud so everybody has a chance to think about this. What angles are considered interior angles in our example? Everybody got an answer?
Yeah.
Give me one angle.
4.
Angle 4. Another angle.
3.
Angle 3. Another?
8.
5. And
8.
6. How is 8 inside or in between the
Oh.
parallel lines?
Oh.
Right?
Oh.
Okay? Everybody good with that?
Yeah.
Interior angles, you're not good with that? See how my parallel lines are right here? The angles that are in between them?
Inside.
Inside. They're inside my parallel lines. Okay? So the only real important thing about interior angles is that they're inside. They're not real glamorous. Okay? So then if we have interior, what's the opposite of interior?
Exterior.
We have our exterior angles. And again, not real glamorous, but again, these would be angles on the outside of the parallel lines. So examples again.
1,
1, 2,
8,
8,
7.
7.
Everybody good with that? Okay. Again, all we can really say about them is that they're on the outside. Not real fun. So from there, then we talk about 2 other things, or 3 other things, really. And the first one are called alternate. What does alternate mean to you?
I think
You can use something else for something, like you can use something else for this.
Okay.
I don't know how to.
Adjustable.
Are we going to use these angles for the find the slope?
No.
Oh.
Do you like adjustable, like if you change it?
Yeah,
Saying that one word, that one word.
Alternate in this situation, all those what you said are like forms of, or one way, yeah. Alternate in our case, we want to think about this where it is. Mr. Colbeck just said. we're gonna think about the opposite. Okay? So, alternate, interior angles is the first thing. So when we talk about alternate interior angles, they're the angles in between again, the parallel lines, and
Yeah.
on opposite sides of the transversal. That make sense? I always get confused.
What does that say? Oh, transversal. Would be 3 and 6.
So, everybody understand what this says?
Yeah.
Okay? Now, when you're dealing with this, and I always get confused, and I'm not confused with what it's saying, I'm confused with what I should tell you. Meaning, I can't always remember how in-depth your book gets. Okay? So this could be a little over the top of what we need to know, but we're gonna include something else. So right now, what would you say my alternate interior angles are? So there's going to be a set of angles. And a set of angles means that there's two of them. So what two angles would be on opposite sides of the transversal of each other and in between the parallel lines? 3 and what's on the opposite side of this transversal? 5. So you're right. On the opposite side, I see where he said what 3 and 4. So in between parallel lines and on the opposite sides of the transversal in a diagonal direction. Does that help?
Yes.
Be a little bit more. So what do we say? Angle 3 and what?
5.
Angle 5? What's my other set?
Angle 4 and 6.
Angle 4 and angle 6. Everybody get to that? Okay, so the diagonal part is really, really important. Now, this is the part that I don't know if I honestly should tell you, but I'm going to tell you anyway. Okay, big star here. If you have parallel lines, which we do, right? Alternate interior angles. So I like to abbreviate a lot when I get to geometry. Are, any idea what that symbol means?
Not
Not equal.
Nope, close.
Congruent.
Congruent. This is congruent. What does congruent mean?
same, like
They're
the same.
alike, but not completely the same.
Mm-mm.
Are they exactly the same?
Exactly the same.
Oh. Well, they don't look exactly the same.
They don't.
Yes, they are. That's what I was thinking of. Yeah, that's what I told Mr. K.
So, realistically, when we say they're exactly the same, they should have the exact same what?
Degree.
Degree measure, exactly right. So, angle 3 and angle 5, yeah, they're upside, this one's upside down, but this is an obtuse angle and this is an obtuse angle, right? Angle 4 and angle 6, this is an acute angle and this is an acute angle. Everybody agree with that? So they're exactly the same. Now this only works if you have parallel lines. So I can still have alternate interior angles if my lines aren't parallel. So if my first two lines that I draw are like this, definitely not parallel, right? Even though they haven't intersected right now, they're going to intersect. Agreed? Because they're going to extend. All right? So when I draw this transversal, I still have, if I do my numbers the same way, 1, 2, 3, 4, bless you. So, angle 4 and angle 6 are still alternate interior angles, but because my first two lines aren't parallel, would you ever say that angle 4 and angle 6 are the exact same thing in that shape?
No.
No. So, special cases when we have parallel lines, then they are congruent. Make sense? That's really important, okay? So if we have alternate interior angles, we probably should also have what? Perfect, alternate
You could have kids, but you decided to do that.
exterior angles. So what do you think?
The same thing but the opposite, the opposite side.
Okay, so we'd say what?
Outside.
Angles on the outside of the parallel lines. What else?
There, possible.
Okay. Yep. So they're on opposite sides of the transversal. And are diagonal from each other. So, in our example right here, don't say it out loud again, let everybody have a second to write all this down and think about it. So, what do you think?
1 and 8.
Nope.
2 and 5.
1 and 7,
No,
Angle
they're
one.
diagonal, they don't cross.
and angle 7, and
Side.
angle
No, but they don't.
2,
Not diagonal from something.
and angle 8.
Oh my gosh.
So, angle 1 and angle 7 are diagonal from each other, and they're on opposite sides of my transversal and on the outside, and then 2 and 8. So again, big star over here. Same big star. If parallel lines, alternate exterior angles are congruent. So again, look at it. Angle 1, obtuse angle. If we got a protractor out, we could measure this angle right here and measure this angle right here, and they should be the same. Now, obviously, mine aren't probably going to be exactly the same because why? Because I drew them, right? I didn't use a ruler in the first place. Okay, so when we look at this, we look at the numbers and we see what they're asking us. Last vocabulary word for this are corresponding angles. What's the word corresponding mean in general?
Work together.
Okay, work together like that. Anything else?
They like go together.
They go together, kind of. Exactly right. So, any idea what you would consider corresponding angles in this?
The ones directly across from each other, like 1 and 3.
No. Great guess, though. Keep that in mind in just a second. We'll come back to that. I'm just asking you what you would consider corresponding angles in this example. You said 1 and 2. Good thought, too. Still wrong. 3 and 6. Getting closer.
1 and 8.
1 and 4, no. 1 and 8.
2 and 7.
2 and 7, nope.
2 and 6.
2 and 6.
Oh, 1 and 5.
4 and 7.
1 and 5.
4 and 8.
3 and 7.
4 and 8.
4 and 8.
3
3 and 7. So, what would we say about them?
They're on the same position.
Okay. So, again, do you see where these are like groups of 4? And these are groups of 4? In a sense, right? So, corresponding angles are in the same spot.
Is there an alternate corresponding?
On different lines.
For the parallel lines, I don't want to say 4 here, and the transversal, right? I don't want 4 here. Where the parallel lines and the transversal meet. Let's say it that way. So, again, for corresponding angles, you gotta think about this as being like a pod. This is one pod and this is one pod. So with respect to the pods, they're in the exact same spot from pod to pod.
Can there be a third one?
There could be as many lines as you want, and then every single one of those pods would continue to do the same thing as long as they hit that same transversal. Exactly right. So, examples of this. I know you already said them, but say them again.
1 and 5.
Angle 1 and angle 5. What else? 2 and 6.
4 and 8.
3 and 7. 4 and 8. So, last thing, do we want to put the star on this one?
Yes.
If parallel lines are corresponding angles congruent? What do you think? Look at them.
No, they're the exact opposite.
1 and 5. If they're in the exact same spot, they got to be the same. So put our star down again. In parallel lines. Corresponding angles are congruent. Yeah. And then when you get into geometry, we'll have one more section of it, or one more thing. All right. We got a lot of stuff here, right? All right, erase. I'm gonna erase this. Everybody got all this stuff?
Yes.
And everybody okay with all that wording? So we're gonna go back to the guesses that people had on the last section, or when I asked the last question. And these are really, really important. You'll use these a lot in geometry. So the first one are called vertical angles. Any idea what vertical angles means? Up and down would be usually what vertical means, right? Up and down. But in this case, we don't really have anything that are truly up and down. So vertical angles are angles that are diagonal from each other in a pod. And I know it's really not a pod, but so in a specific pod, it's the angles that are directly diagonal from each other. So what angles would you say make vertical angles?
2 and 4.
2 and 4, somebody said.
6 and 3.
Yeah, he said that. Angle 2 and angle 4. What else?
6 and
6 and 8.
1 and 3, somebody said.
5 and 7.
5 and 7 works.
I'm almost that tall.
And what was the last one? 6 and 8. Alright. Do we need to put our star on this?
Yes.
Yes. Okay? But we get to eliminate the first part. So just a big star. All sets of, again, I'm lazy, vertical angles are congruent. All sets. Let's say to each other, I guess. I would hope you understand that. This group's not the same as that group, right? These two and these two aren't. So they're just to each other.
The opposite of acute. I mean, what is it? Obtuse.
The obtuse, yes. Everybody good with that? So then another vocabulary word, we say adjacent angles.
Adjacent.
right next to each other.
But they're not.
Two angles next to each other.
So all we need.
Where did we have adjacent just recently?
The one thing where you do the X and then like you make a table and then like SOHCAHTOA, you know?
SOHCAHTOA, yeah, right. The trigonometry stuff we had adjacent. So realistically, adjacent angles, kind of like interior and exterior, not real glamorous. They're just next to each other. All right. They might have a special characteristic, but not necessarily. So if you want to get a little bit more specific about this, you can see up here, these would have the same vertex
But not the same.
and share one side. So if I said angle 1 and angle 2 here, those are adjacent to each other. They're right next to each other. They touch each other. Okay? They share this side right here, and their vertex would have the same thing. But realistically, they're not always congruent. They're very seldom congruent. Sometimes, though, they could form a linear pair, which means that they form a line. All right? So there's other things that could happen to them, but not necessarily. A lot of stuff, right?
Yep. It's about drawing a line between D and the lens.
Next vocabulary word. You might have heard of this already. Complementary angles.
I was on TikTok. Oh, I know.
But
I was on TikTok. It's like, be a millionaire, and he had a lifeline, and he called his 11-year-old son, and he's in what, 5th grade, and he knew what it was, and it was complimentary, and the question was, what's the name that you add up the angles, add up to 90, something like that.
perfect.
It was there was adjacent, complementary, vertical, and I forgot the other one.
How much money did he win?
Two angles that add up to 90 degrees. Now, when we get into geometry, we would say this would be two angles two or more angles.
Well, they'd have to be connected.
Okay? And they'd have to be connected. Well, not necessarily. Because I could have one angle over there and one angle over here, and they could still be complementary.
Yeah, but they have to finish the part of the line.
No, because I could say,
Wait,
if I had this angle right here and this was 37 degrees, I would say if I wanted those two angles to be complementary, even though that they're not look like, what would x be here?
oh,
43. No,
I was thinking about
33.
something.
Then I'm going to take 90 minus 37, right?
No, I'm so wrong.
We know.
Hold on.
Okay?
It'd be 53, yeah.
53.
Yeah.
Okay? So again, like I said, when we get to geometry, we would say two or more angles, because what Mr. Colbeck is saying, I like proving Mr. Colbeck wrong, so that's why I wrote that one. But realistically, they're going to probably show us this. How do I know that that's for sure 90 degrees?
Ah, the box.
I got the box. And then we draw something like that, right? And then if they say this is 37 degrees, they would say, what is x? Those two would be complementary, right? No argument about those are complementary because of the box. Make sense? Okay? So what was your other group? Supplementary angles.
Is that what?
Okay?
It's when they both
Yeah.
do the same thing.
So supplementary angles are two angles that add up to how much?
180.
180?
So that's what I was talking about.
Yeah, that's what you're talking about.
Ow.
So realistically, again, when we get into geometry, we would say two or more angles that add up to 180 degrees. But for our sake right here, if they add up to 180 degrees, what should they make?
A line.
A line, right? So we have a line right here, and then we're going to put some ray going out of there. So we'd say this is angle 1 and this is angle 2. So realistically, if I have two angles that make up 180 degrees, one angle should be what kind and one angle should be the other.
Or they can both be right.
So this would be an acute angle, this would be an obtuse angle, and normally, or I don't want to say normally, but predominantly a lot of the time, that's what they're gonna be, or what did you say, Mr. Galvin?
2 right angles.
Two right angles, right? Two right angles would always make up supplementary angles. Okay? So again, they're gonna say if this is a line, and angle 1, they'd say the measure of angle 1 is equal to 115 degrees. What's angle 2? 65?
Would you need the play button?
I don't need the play button. The play button only shows me that they are parallel to each other.
Oh.
They don't necessarily say that they're aligned. So realistically, this is where somebody, and I'm not naming any names, but they could look at it and say, well, I don't think that's a straight line because there's a little something, right? But we are going to say anything that looks like a line pretty much is a line, unless they somehow show you a difference. Okay? Last one. Last one are perpendicular lines. So, what usually goes with perpendicular? It's what we started out with. Parallel lines usually go with perpendicular lines. So parallel lines never cross. What do perpendicular lines do?
Cross.
They cross. Okay?
They intersect.
It makes a T.
Two lines that intersect and form what? If they're going to intercept and form that T, right angle. Form a 90-degree angle. So, what's the symbol for perpendicular? If this is parallel, what's perpendicular?
Nothing.
This is perpendicular. An upside down T.
Yeah, we.
Okay? Sometimes you'll see a little box here, but you don't really even need a box. Okay? So, again now, if somebody ever says that you have perpendicular lines, they cross and they form 90-degree angles, so we know that each of them have to be 90-degree angles. If this side is 90 degree and this is a line, this one has to be, right? 180 minus my 90 degrees. Okay? So turn to page 495, please.
Mr. King, my notebook has a little hiding spot.
It does?
Yeah.
That's cool.
Sweet. You can put all your money in there. Here we go. Everybody on page 495? We're looking at number 3. Here I will tell you once again, like I tell my geometry kids and they never pay attention to this. You have to read the directions. If you cannot read, come up and I will read you the directions. I'm not being mean. I honestly don't know if some of our kids can read because they never read directions.
Please excuse this interruption. Boys junior high will have practice after school tonight. Track practice for junior high boys tonight after school.
So what I'm saying is, look at the little portion right above number 3. It says, in the figure at the right, L is what to M? Parallel. Notice they didn't put the little play button on there, but they told you that. So realistically, the first thing you should do is rewrite the problem in your paper and then put the little play buttons on there, if you need to see that. K is the transversal. If angle 1 is 56 degrees, find the measure of each of the other angles. If angle 1 is 56, what is angle 2?
56.
Why? So what do we call those?
No. Corresponding.
Corresponding.
No.
No, complementary.
No,
Adjacent. Alternate.
no. Vertical angles, so this is why it's important to know all that stuff. Number 3, if angle 1 is 56 degrees, what is angle 3? And why?
56.
56 is correct, but why?
Because it is,
No.
vertical. No, it's adjacent.
Adjacent.
No.
Alternative.
It's-
It's one of the first ones we did.
It's corresponding.
Corresponding angles,
Yeah.
right? What did corresponding mean again?
In the
If
same
angles are in the
spot
same
with the
spot.
parallel.
In the same spot. See how they're in the same spot of those pods? Now my pod is kind of a left-handed pod and a right-handed pod instead of the top and bottom pod. Everybody good with that? All right, number 4, or sorry, angle 4. So we got to go back to angle 1. What do angle 1 and angle 4 have in common?
They're
Both like
Oh, they're on the outside. What is that called?
Square. Exterior.
Alternate exterior angles.
no, they're
No.
not alternate. It's
Complement. No. Just
no, it's
exterior.
something.
They're just exterior, so that can't happen. Maybe I didn't write this one down. Because I don't remember them telling me to do this.
Wait.
They average 90.
So would it be the same thing if the example was forward? We defined one.
Okay, so we need to go back and, think about this right here. Look at where angle 4 is. Is that what they said? Yeah. Look at angle 4 and look at angle 3. Did we just find out what angle 3 was?
Yeah.
Okay, so look at angle 3 and 4 and compare it to this right here. Do angle 3 and angle 4 make this straight line?
Yes.
Yeah.
And do they share this one segment in between?
Yeah.
So they would be considered what to each other?
Supplementary.
Supplementary. So what was angle 3?
56.
So if angle 3 is 56, what's angle 4?
124.
Because you did what?
Subtracted
From?
180.
180, because they're supplementary. Okay? Alright, we'll do the rest tomorrow.